Welcome back, ladies and gentlemen, to the free response question review. Today we will be looking at the 2017 Calculus BC exam, question number 4 from the non-calculator portion. It is the problem that is revolving around a boiled potato, which in 2017 went down in infamy among its counterparts on the AP exam. But I think we can handle this one. It's a pretty basic FRQ once you kind of demystify it. The reason why this was so difficult was that people didn't recognize the problem for what it really was. It reads, at time equals 0, a boiled potato is taken from a pot on a stove and left to cool in the kitchen. The internal temperature of the potato is 91 degrees Celsius at t equals 0, and the internal temperature of the potato is greater than 27 degrees Celsius for all time greater than 0. The internal temperature of the potato at time t minutes can be modeled by the function h that satisfies the differential equation dh over dt equals that thing, where h of t is measured in degrees Celsius and h of 0 is 91. So, in part A, after all that exposition is over, in part A, they are asking us to write the equation of a tangent line to the graph of h at t equals 0. Alright, and we're going to do some other things, but we will take care of that first. So before I move forward, I'm just going to write down what dh over dt is, and that's negative 1/4, and then h minus 27. And so, since I'm going to write the equation of the line at t equals 0, that means that this 0, 91 is going to play a pretty critical role in part A. So in A, I can start us off with y minus 91 is equal to some sort of t minus 0. And it looks like we're missing a slope, right? And luckily we already have the derivative, so all we have to do is plug in the appropriate pieces to find the slope at that moment in time. So what's that going to look like? Well, that's really dh over dt at the coordinates 0, 91, and that's going to equal negative 1/4 times a blank space minus 27. Now, if you've gotten this far, the hardest thing about this, and the mistake everyone's going to make, is they're going to plug 0 into there because we're used to plugging in the x coordinate there. But in this case, because it's h minus 27, this ends up becoming 91 minus 27. So you end up getting negative 1/4 times 64 because of the result of 91 minus 27. These guys are going to cancel, leaving you with negative 16. So right here, this is the equation of the line that you're going to be using in the second part of part A, which is to use this equation to approximate the internal temperature of the potato at t equals 3. So that's a piece of cake. I'm going to plug 3 in for t. So what I get is y equals negative 16 times 3 plus 91. And that's going to be 91 minus 48, which is going to be 43 degrees. So pretty simple right there. Pretty simple problem. All right, let's move on to part B. It says use d squared h over dt squared to determine whether your answer in part A is an underestimate or an overestimate to the internal temperature. Okay, so we can go ahead and do that right here. I'll go and move them here. So what is the second derivative of this thing? Well, that's going to be, I'm going to kick out the negative 1/4, and I'll just go and derive the inside, which is going to be the h minus 27. The derivative of h with respect to t is going to be dh over dt. It's not going to become 1, because what I'm doing is I'm deriving with time being my input here. So the derivative of h would then become dh over dt. So let me erase that part real quick, because I don't want to keep that there. So from here, what's that really going to equal? That's going to equal negative 1/4, and then whatever dh dt was from the beginning. So that's going to be negative 1/4, and then h minus 27. So these guys can combine out to become positive, and I think we should do that. So 1/16, and then h minus 27. So that is my second derivative. So from here, if I'm going to try to tell whether or not my linear approximation is an underestimate or an overestimate, the second derivative becomes necessary because the concavity will tell me whether or not I'm above or below. But how could I possibly determine the concavity of this thing at t equals 3? Well, if you go back to the original problem, it actually implies it at some point. It says the internal temperature of the potato is greater than 27 degrees for all time greater than 0, which means this expression on the inside here, this expression on the inside is always positive because h will always be greater than 27 as long as t is greater than 0. And we're not going back in time. This is not back to the future. So we're going to always be positive for the entire expression. So what we can say is d squared h over dt squared is greater than 0 for all t greater than 0. We can say, therefore, h is concave up, and therefore an underestimate. Okay, cool. So that's part B. Let's go ahead and clean up the board a little bit, and then we'll head to part C. Part C, it says, for time being less than 10, an alternate model for the internal temperature of the potato at time t minutes is the function g that satisfies dg over dt equaling negative g minus 27 to the 2/3, where g of t is measured in degrees Celsius and g of 0 equals 91. Find an expression for g of t, and then based on the model, what is the internal temperature of the potato at t equals 3? So, because they are asking me to find out what g of t is, we are now going to separate this differential equation and solve for g. So from here, I don't need the dh over dt anymore. So I'm going to go ahead and actually delete him too. I don't need you. So now I'm going to go and write down the dg over dt function. Okay, so let's go and separate terms. This is the meat that goes with this potato in this problem here. So let's go and separate the terms, which is where we're going to get the bulk of our points marked off if we don't do it. So 1 over g minus 27 to the 2/3 dg is equal to negative 1 dt. Before I integrate, I'm going to go ahead and call him g minus 27 to the negative 2/3 dg is equal to negative 1 dt. Integrate on both sides. Looks like I'm going to get g to the g minus 27, my apologies, to the, looks like to the 1/3 times 3 is equal to negative t plus c. Now, nothing weird is happening here, so it's not like I have an absolute value with an ln or anything like that. So at this point, I think solving for c off the cuff might not be a bad idea. So I'm going to go ahead and do that. So since my initial condition is 0, 91, I'll go ahead and say 3 and then 91 minus 27 to the 1/3 is equal to negative 0 plus c. So c is going to equal to, this is 64, cube rooted is going to be 4, so 12 equals c. So what do I really have? I have 3 and then g minus 27 to the 1/3 is equal to negative t plus 12. Let's go ahead and divide out that 3. So I'm going to get g minus 27 to the 1/3 is equal to, you can simplify this or not, I will go ahead and do that, t over 3 plus 4. Go ahead and cube everything. So cube it all. So I'm going to get g minus 27 is equal to negative t over 3 plus 4 cubed. And then from here, g will finally equal negative t over 3 plus 4 cubed plus 27. So I'm not done yet. Now I got to find out what the internal temperature of the potato is at t equals 3. Well, conveniently, g is going to equal, looks like negative 1 plus 4 cubed plus 27. Well, that's 3, so 3 cubed is 27 plus 27, so g equals 54 degrees at t equals 3. Okay, I think that just about wraps it up for the potato problem. Go ahead and leave any comments or questions in the comments area. I always appreciate the feedback, and I will see you in the next video.